In some languages, like C++ or Python, you can redefine how an operator works in the context of specific classes. So for example, you could say that when it comes to dogs, greater than compares the size of the dogs. Now in Java, we don't have that capability. So instead, we're going to turn to interface inheritance to help us out. So what we can do is create an interface that guarantees that our class has a comparison method, and then we'll have the dog class implement this interface. Now, of course, this requires that we change something about the dog class, and we'll talk about how this isn't a big practical problem in the real world later. But basically, in this way, we're specifying to the world, indeed, anything that is what we'll call an OurComparable can be compared to other items. Okay? So in this case, we'll create an interface called OurComparable, and more specifically, it will have a compare_to method that takes any object, and it returns something that tells us whether or not this item is bigger or smaller than the object passed. And then we'll have dog implement this interface, and then ultimately what our max function will now do is instead of taking an array of objects and returning an object, it'll take an array of OurComparables and it will return an OurComparable. Okay? So let's actually just jump in and try and write this thing. This is the code that we had in our lecture slides, and we can see here that this is not compiling. It is unhappy. So let's make a new interface, just as I said. So interface, we'll call this thing OurComparable. And in this interface, we're going to set the specification up. Well, actually first, let's do the int function. Public int compare to object O. Okay. We could have made it a Boolean, but I'm going to make it an int to reflect what is common practice with real Java code. And so what this function is going to do is return -1 if this is less than O, return 0 if this equals O, and finally we'll return 1 if this is greater than O, okay, where O is the other object. And actually, we don't really need a description of this class. This is good enough for our purposes in this lecture. So now that we created this OurComparable interface, we can go to the dog class and we can say implements OurComparable. And so naturally, in order to implement OurComparable, we need to have this method. So let's do that. So we want to compare to other objects. Okay. So this returns -1 if this dog is less than the dog pointed at by O. Okay. And so forth. You know the rest. 0 if they're equal, greater than 1 if it's bigger. So when we write this function, we need to somehow compare the size of us to the other dog. And so we might try and do something like if this dot size is less than O dot size, return -1. Else if this dot size equals O dot size, return 0. And then we can do finally return +1, or just 1. However, of course, there is no size symbol in the object class, right? So there's no size in an object. So we need to first cast. And so what we'll do is we'll say dog dog equals dog O. So we're comparing ourselves to another dog. I took this from, I was on Big Island in Hawaii a while back, and there was a guy who rents kayaks near Kealakekua, and his name Ehu and Kai, and so I forget if I think the guy's name Kai and the dog's name Ehu, and he had another dog running around, and I said, "What's that dog's name?" And he just goes, "Da dog." So anyway, in honor of Da dog, we have cast Da dog as follows. So in this case, we'll say dog and dog, and that gives us a compare to method. Okay. Now finally, we can go to maximizer, and we can say instead of an array of objects, we'll have OurComparable. Instead of returning an object, we'll return an OurComparable. Oops, OurComparable. Okay. And instead of doing greater than, we'll do that same thing we did in an earlier lecture when we were comparing strings and say, let's set aside the result of the comparison. So in this case, items I dot compare to items maxx. And then we'll make a decision based on comp. So if comp is greater than 0, that means this item is bigger than the currently largest. Maxx will get set equal to I. So now let's try running this. Let's see what happens. We get Artemisios says bark. So we've grabbed the largest. In an ideal world, we'd write some kind of tests, but it's a lecture. Now I want to change one little thing before we move on, which is to note that this code is a little long, and there's a common trick that will help explain to you why this strange interface exists. So instead of saying if this.size less than utterdog.size, return -1 and so forth, we can just do return this.size minus utterdog .size. And we're going to modify our OurComparable interface a little bit to say returns negative number if this is less than 0, returns 0 if they're equal, and returns positive number if this is greater than O. So in effect, what we can do from now on is just return, in this case, the difference between the sizes. So say my size is 2 and utterdog's is 5, then I'll return -3, meaning I'm smaller. So this is a really common trick in comparisons. And so we'll say here returns negative number. Okay, just worth seeing. Let's double check, make sure everything worked once more. Okay, still working, good. So let's reflect a little. We created an interface called OurComparable. We made it so that dog actually implements OurComparable, and then we changed our our max function to take advantage. So this interface here, our specification, right? We always, when we think about what the actual interface was, the thing that we're inheriting was that it returns a negative number if this was less than object, a positive number if this is greater than the other object, and 0 if they're equal. And one tiny little thing you might have noticed, I don't know, maybe you didn't, is that in our OurComparable interface, we have here object. Could this have been OurComparable? Sure, won't change anything about how the code functions, would work just as well. So there's no meaningful difference between those two. So ultimately, what our code ended up looking like was this. And the only last thing to mention, of course, is that if we tried to actually compare a dog to a cat or a horse, it would fail. Because, well, if you try and cast it as a dog, then that's not going to work so well. Okay? So this approach, while it does work, suffers from the danger that a programmer could accidentally try and compute the try and compare the size of two different things that weren't the same class, and that could cause some trouble here. Okay, but we'll see how to fix that in a little bit. Okay, so what are the benefits of this approach? Well, it means now we finally achieved our dream, right? If we look at our code, this maximizer function will work on anything that is an OurComparable, which is lovely. So we don't need some kind of special max function in dog. All we need is that dogs are comparable. And so now our code, we could in principle have a function that gets any kind of items from a file. This could be a file of horses, cats, dogs, fish, potatoes, S-lists, A-lists, who knows. As long as those things implemented OurComparable and the getItems function knows how to somehow read them from the file, then this maximizer class's max function will be able to give the largest, which is quite nice. So what we'll do next is make sure all that syntax works, but I'll move on to the next video to make sure you have a chance to pause and digest. And we'll come back to this quiz in the next video.